Okay, good morning. It's Miss Trangle. This is 11-2, section 11-2. Some of the dates and things are going to be off. It's just really time consuming to try to change the PDF, so we're just going to go with that. Anyway, we're on section 8-2, area of circles and circle sectors. So our essential question, how do you find the area of a circle and a circle sector? Our learning target, I can find the area of a circle and a circle sector. So where does the area formula of a circle come from? You may have heard, so make sure you're getting your formula down here. Here's the area of a circle. A equals pi r squared, pretty common. R is the radius. The radius is the center to the outside of the circle. Where does that come from? So I always like to show people this, and some people it's like a big aha moment and they love it. Some people hate it and they're like, never show me that again. But I'm going to include it. And if it makes sense to you, that's wonderful. And if it doesn't, you can follow up with me, or you can accept the formula as it is too. That's also fine. Okay, so a circle, here's your circle right here. If you were to divide your circle up into little sections or sectors and arrange those into kind of a rectangle or a parallelogram, that's what they are doing. So the circumference of a circle, circumference is 2 pi r. The circumference, the distance around this circle, is basically being split into two parts in this rectangle, the top half and the bottom half. Because half of your circumference is up here and half is down here. So half of your circumference, instead of 2 pi r, if you take half of that, that would just be pi r. So the length of this rectangle, maybe I'll circle it or make it yellow here. The length of the rectangle is pi r. The height of your rectangle or parallelogram is the radius, one of these little radiuses. So the area of a rectangle or parallelogram is base times height. The base, if you look over here, the base is pi r. The height is r. If I multiply pi r times r, the r times r right here become an r squared. So pi r squared. And that is where the formula that you find in textbooks and on the internet, that is where that actually comes from. So I just like to show that because I think it's kind of cool. All right, next, a circle sector. Sometimes people call them wedges. You can think about a piece of pie, a piece of circle, cheese, something like that. Officially, we call it a circle sector. So what is a circle sector? It is a fraction of a circle. Fraction of a circle. The formula for that, I'm going to call it the area formula of a sector. So I'm going to abbreviate the area formula of a sector. Kind of similar to arc length and S in section 11.1. We're still using that m over 360 times pi r squared, because instead of finding the area of the whole circle, you are finding a fraction of the circle. So if I'm finding this shaded part, instead of the whole circle, I just want a fraction of it. And that m over 360, m stands for the measure of the central angle. All right, we are going to move on to the examples. So example 1, find each indicated measure. Part A, the area of a circle with a radius of 2.5 centimeters. So for part A, that's just finding the area. I'm using area equals pi r squared, just a regular old circle. My radius, it tells me right there, is 2.5. So this can be put into your calculator. The whole thing can be put into your calculator. And remember, for big ideas, they want you to use the pi key and round to the hundredths place, 2 decimals. So 19.63 centimeters squared. And when you're rounding to the hundredths place, 2 decimals, you are looking at the third digit and rounding accordingly. All right, part B, we want the diameter of a circle with an area of 113.1 square centimeters. So they are giving us the area. So I'm still using my area formula, A equals pi r squared, but they gave me the area, the answer, so I'm kind of working backwards. I'm putting 113.1 in for area. I am solving for radius, and then we will go from radius to diameter. So first, let's divide out a pi. So 113.1 divided by pi is about 36. Then to find the radius, instead of r squared, to undo a square, I take the square root. Since we are talking about a circle, we're going to take the positive answer. 6 is my radius. Be careful, the question asks for diameter. Diameter is twice the radius, so 12. And that's example 1. And you can always pause if you need more time on any of this. All right, example 2. Okay, so example 2 is kind of applying some circle stuff to real world situations. Population density, how dense is that? So think about a place like Manhattan, New York City, really a high population density, a lot of people living in close quarters. Think about a rural area, maybe up northern Minnesota, a low population density. So this is a very important statistic that we need for providing all kinds of city services. And tax revenue, we use it for deciding how many representatives politically a community gets, all kinds of things. Okay, so what is population density? It is basically a fraction, a ratio. It is the number of people living somewhere divided by the area. It's usually given in terms of square miles, but you can also use it in terms of city blocks, things like that. If you think about our current situation, areas with a higher population density, again, New York City, being harder hit by COVID and the virus because there's more people in a small concentrated area. So I'm sorry to bring that up, but I just wanted to, understand that these concepts they do figure into our everyday lives. All right, so part A, about 430,000 people, which is about the population of Minneapolis, by the way, a little more. Minneapolis is about 400,000, live in a 5-mile radius of a city's town hall. Find the population density. So for part A, we are just doing, again, the number of people divided by the area. So the number of people, that is 430,000, divided by the area. The area, by the way, should be pi r squared, so pi times 5 squared, so that's 25 pi. That's the area that we are including in part A. So I'm going to do 430,000 divided by 25 pi. I'm not going to even bother multiplying that out right now because then my answer will be a little bit off. So I get 5,475 people per square mile. And I rounded that to the nearest person rather than the hundredths place because I think it says find the population in people per square mile. So I rounded it up to the nearest person. Okay, part B, we are looking at the same concept, population density. Now we're getting different information. A region with a 3-mile radius has a population density of 6,195. So they are giving us, if you think about your formula, they are giving us the population density, the answer, and we are trying to find the number of people. So they're giving us population density. So I'm going to put that in 6,195 equals the people. We don't know that. You can put an X if you want instead of people or something like that, divided by the area. So the area, I'm going to go ahead, hopefully this makes sense to people. The area is going to be 9 pi. How did I get the 9 pi? I'll make a little arrow over here. Area equals pi r squared. My radius was 3. 3 squared is 9. So that's where this came from. So here's my equation right here. I'm trying to find, I'll circle it in red, the number of people. So I want that by itself. To solve an equation with a fraction, you want to get rid of your fraction, your denominator. A fraction is division. The opposite of division is multiplication. So I am multiplying each side of my equation by 9 pi. These 9 pi's cancel. basically what I'm typing into my calculator is 9 pi times 6,195. And I am getting 175,000. Okay, I'm getting 175, 159.5. So if I were really to round that up to the nearest, to find the number of people, I would round that up to 160 people living there. The rounding, we won't be super picky about that, but that is what I would do. All right.